Okay, so 4.5, the second part here is all the examples. And so if you read through, like the previous slide here, I kind of skipped over one, but it just tells you all the things that we talked about right there at the end of the part 1 notes. So make sure you watch them and just kind of put it all together in it. So here it says use the graph of f of x equals the absolute value of x to obtain the graph of g of x equals the absolute value of x plus 3. All right, so remember we talked about some tables here. So for f of x or y equals, whichever, is equal to the absolute value of x, we had that parent table where we used the x values from -2 to +2, and we took the absolute value of them, so we came up with our y values. And so now for our new function here, it says g of x is equal to the absolute value of x plus 3. Well, first, what do we expect that x plus 3, or that plus 3 to do to our graph? Well, remember, this is in the form of the absolute value function, so it's a times absolute value of bx minus h, and then a plus k. That 3 is in the place of the k, and so if you look at the notes that we took, it's going to tell you that k is a vertical shift, and a plus k is going to go up k units, so this is going to go up 3 units. So I expect to see my graph raised up 3 units. Now for my table here, we're going to take all of the x and y values from our parent table that I wrote there in blue, and then we're going to apply that plus 3. So does that plus 3 affect my x or my y? Well, if it's going to affect the x, it would have to be inside with the x. So it is not. So that means it's going to affect your y. Remember, y does what it's supposed to. What does it say? It says plus 3, so we're going to add 3 to our y's. So we're going to take all of these x values here, and we're just going to recopy them because we're not changing our x's. And we're going to take all of these y values, and we're literally just going to add 3 to each of them. And so we got 2 plus 3 is 5, 1 plus 3 is 4, 0 plus 3 is 3, 1 plus 3 is 4, and 2 plus 3 is 5. And then we can graph those points. Whoops, got it wrong there. And so here's our new graph. We knew that the absolute value of x was going to be V-shaped, and it didn't tell us to graph the original one, but if we did, here is our points, and so we could see that it is literally that graph just shifted up 3, like we said. All right, again, this is in that big group of notes that we talked about at the end of part 1. So the example 2 says use the graph of f of x equals the square root of x. Obtain the graph of g of x equals the square root of x minus 4. So first thing is our parent function is the square root of x. And so we're going to go pull that table. And remember, that's one of those odd tables. We always use -2 to 2 so far unless it's a square root or a radical, so a square root or a cube root. And so we picked 0, 1, 4, and 9 for x values because we were able to take the square root of them to find our y values. Now, remember, this is also that y equals a square root of bx minus h plus k. So let's look and see what that minus 4 is going to do. The minus 4 is underneath with the x minus, so it's going to be our h value. Our h value tells us that it's going to be a horizontal shift. And remember, anything inside with x is the opposite. So we think because it's a minus 4, we'd go to the left 4, but it's inside with x, and so we're actually going to go to the right 4. All right, so for my for my transformation table here so that I can graph it, is that minus 4 going to affect my x or my y? Well, you can see it's inside with x, so it's going to affect the x, but remember, x always does the opposite, so we're not going to really subtract 4. What's the opposite of subtracting? Adding. So we're going to take all of our x's here, and we're going to add 4 to them. And then we didn't do anything to our y's, so we're just going to bring those over. So I'm going to go ahead and do that first. Take care of the easy stuff, then add 4. So 0 plus 4, 1 plus 4, 4 plus 4, and 9 plus 4. And then we can graph those points. And And I know 913 is off our graph. I'm sorry, 13.3 is off our graph, so you can just guesstimate it or you don't have to. Either way, we can see that that is what our graph looks like. And if we were to graph the original one, like I said before, it didn't tell us we had to. But if we did, we could see that our points literally just moved to the right 4. Okay, moving on. In example 3 here, says we're going to use the graph of f of x equals a cube root of x, that's our parent one, to obtain the graph of h of x equals a cube root of negative x. So the cube root, we had a parent table for it, and again, remember it's a radical, so we didn't use our normal -2 to 2. So make sure you look back at it if you need to. Remember, this is in the form of y equals a cube root of bx minus h plus k. And so when we want to know what did that minus do in front of that x, we can see that minus is in the place of the b. Well, it tells us if it's a negative b that we're going to see it reflect across the y-axis. All right, so is that going to affect, that negative, is it going to affect my x or my y's? Well, where's it at? Is it inside with x? Yes, it is. Therefore, it is going to affect my x's. Remember, a negative x is the same thing as a -1 times x. And with x, we always do the opposite. So we're not really going to multiply it times that -1. We're really going to divide it by -1. And I know multiplying and dividing by a -1 won't change the answer, but if it had been a 2, it would make a totally different answer, okay? So remember, with x, do the opposite. All right, so we're going to divide all of these x's by -1. There's nothing not inside with the x to affect my y values. So all of my y's here are going to stay the same, so I'm going to go ahead and bring them over. And I'm going to divide all my x's by -1. And then I'm going to graph those ordered pairs. Oops, I'm graphing that totally wrong too. All right, so let me look at the right table this time. No, that was, yeah, I was wrong. Sorry about that. And so we can see that our graph looks like this. And again, if we graphed our parent function, we can see that it did just reflect across, let's pretend that's correct there. Sorry about that. So we can see that it did just reflect across the y-axis. This piece that was right here is now over there, and this piece that was here is now over there. So it did reflect across the y-axis because the y is in between them. All right, example 4 says use a graph of f of x equals the absolute value of x. Obtain the graph of g of x equals 2 times the absolute value of x. So again, they gave us our parent function. We looked at that one in example 1. But I'm going to write down my parent table because I like to be able to see it each time. Of course, you're using your notes, so you can just flip it back to your notes if you want. I also like to be able to write on mine. And so that's why I rewrite it even when I'm doing it not on the screen for y'all. All right, so we're also, remember, we're looking at absolute value of x. So it's a times the absolute value of bx minus h plus k. And so we're looking at this, and we see we have this 2 here. Well, that 2 is in the place of my a, and it's being multiplied. Therefore, well, it's outside of the x. So first, that means it's going to be vertical. Remember, inside with x is horizontal because x is your horizontal axis. It's being multiplied at the beginning, so we know it's going to be a stretch or compression. Now remember, if it's outside, not inside with x, it's going to do what it's supposed to. This says 2 times. When you multiply something by 2, it gets bigger, so therefore it's going to be a vertical stretch by a factor of 2. So we're just going to put by 2. All right, so now when we go to actually be able to create our table so that we can graph this, is that 2 going to affect my x or my y's? Well, it's not inside with x, so it's not going to affect the x. So it means it's going to affect the y's. How? Well, what is the 2 doing? It says 2 times the absolute value. It's being multiplied. Remember, y does what it's supposed to, so we're going to multiply our y's by 2. So our x's aren't going to change, so bring them over. And all of our y's are getting multiplied by 2. And then we can graph those points. Is absolute value, so it's going to be that V-shaped. And then, just like I did in the others, if I take and I graph the original one, ask yourself, did it get vertically stretched? And so remember, vertically stretched means from the top and from the bottom. So if I pull from the top and the bottom here, if I stretch it, I'm stretching it up and down, that's going to make that graph become more narrow, which is exactly what happened. All right, example 5 says to use a graph of f of x equals x squared to obtain the graph of g of x equals 1/2 x quantity squared. All right, so there's my parent function. And so we have our parent table that we talked about. And so we're going to pick our normal x's, -2 to +2. And then we just went through and we squared each one of them. And we came up with that table. Remember, this is a quadratic, so our general form is y equals a times bx minus h squared plus k. Now the only thing we have going on in this new one is we have that 1/2 inside beside the x. So that is my b. Because it's inside with x, it's going to be horizontal. It's being multiplied, which means it's going to be a stretch or a compression. Now, when we multiply something by 1/2, it usually gets smaller. But remember, x does the opposite. So multiplying by that 1/2 is actually going to make it get bigger. So it's going to be a stretch by, and the reason it's a stretch is because x, we're not going to multiply by the 1/2. We're really going to divide by 1/2, which is the same as multiplying it by 2. All right, so for my table, for g of x equals that 1/2 x quantity squared, that's just a way of saying that the 1/2 is also squared as well, okay? So is that 1/2 going to affect my x or my y? Well, it's inside with x, it's going to affect the x. It says 1/2 times x. We know we do the opposite, so we're really dividing by 1/2. Now, we usually don't like to divide with fractions. So remember, you learned that keep it, change it, flip it. So keep it, change it, flip it. So we're really going to take that x and keep it. We're going to change and divide to multiply, and we're going to flip that fraction. So we're really just multiplying it by 2. All right, so we're going to multiply all of our x's by 2. There's nothing not inside with the x in this problem. Now, guys, remember, I know the square is not inside, but the square came from the parent table, okay? The exponent, the cube, the root, the numbers like that don't affect our table. Those tell us which is our parent table. All right, so don't worry about the square, or if you have a cube or a cube root kind of thing. Don't worry about those. Those just tell us the parent table. So we're going to take our x's times 2. Our y's aren't going to change, so I'm going to bring our y's over. I'll multiply my x's by 2. And I'm going to graph that. All right, remember, quadratic is the parabola, it's that U-shaped. So that's what it's going to look like. Again, if I graphed my parent one, it would have looked like this. Now, we said this is horizontal, so that means from the left and from the right. If I took that blue parabola and I stretched it to the left and right, would it look like my pink one? And yes, it would. The horizontal stretch is going to make that graph become wider because we're stretching it from the left and the right. All right, and then example 6 here. So it kind of puts them all together. So it says use the graph of f of x equals x squared to obtain the graph of g of x equals -1/2 times x plus 1 squared minus 2. Well, again, the first thing is my parent function is f of x equals x squared. And so we have our parent table, and it's just the one we just used in the previous example. All right. Now, and so we're still using that y equals a times the bx minus h squared plus k. And let's talk about what each piece is going to do. So take it piece by piece. That negative is with that a, and so negative a is going to reflect across the x-axis. The 1/2 is the a, so it's outside of the parentheses, so we know it's going to be vertical. It's being multiplied, so it's a stretch or compression. When you multiply 1/2, something gets smaller, so therefore it's going to be a compression by 1/2. Oops, forgot the y and the by. All right. The plus 1 is inside parentheses, so it's going to be horizontal. It's being added or subtracted, which means it's a shift. A plus 1 will actually go to the left one, because remember, inside with x does the opposite. And then the minus 2, it's outside of parentheses, so it's vertical. It's being added or subtracted, so it's a shift. And it's outside parentheses, so it does what's supposed to, so it's going to go down 2. So when we go to make our table here, okay, we got a lot of things going on. So look at your x's. What's inside with x? Just the plus 1. So we know we're going to take our x's and we do the opposite, so we subtract 1. Now for my y's, what are we going to do? Well, we have this 1/2 times, and then we have a minus 2. We know PEMDAS tells us to multiply first, so we're going to multiply by negative 1/2, and then we're going to subtract 2. So I'm going to do with my x's first. I'm going to subtract 1 from all of these. And then I'm going to take my y's and I'm going to multiply them by negative 1/2. And then I'm going to subtract 2 from that answer. All right, so when I take that, I'm going to do it up here at the top. So when I take 4 times negative 1/2, I get negative 2, and then I subtract 2, I get negative 4. So my first y is going to be negative 4, but look, the last y is the same, so it's also negative 4. And take my second y, the 1, I'm going to multiply it times negative 1/2. Negative 1/2, I subtract 2, and I get negative 2.5. And my next to the last y was also the same, so we're also going to get that there. And then our middle y there was a 0, multiplied by the negative 1/2, we get 0, subtract 2, and we get negative 2. And then I'm just going to graph those points there. All right, when it's a parabola, there's where we graph that U-shaped, and there is our graph.